So I picked up this super cheap automatic soap dispenser here with the idea of using it with hand sanitizer. And originally that didn't work out so great, and I'll show you how I was able to get this to work really well. But more importantly, once I tore it down, I decided to take an average current reading from the battery, and that's when I discovered that it was pulling like 270 microamps, as you can see here, from the battery in standby. Now, for somebody like me who's obsessed with low power design, I had to improve this. So I decided to take complete control over this dispenser and make it a whole lot better. So now it's much more low power. The battery will last way longer. And we've got control over everything with the dispenser, how long it dispenses out. And even if I kept my hand there like this, it doesn't keep dispensing. Or if you wanted it to, it could. You can control how much, sanitizer you want to be sprayed out. All kinds of cool stuff. So let's go ahead and get started, and I'll show you how I designed this thing. So there's a lot to talk about here, but we'll just start with the hardware here. Now, I did say that I made the dispenser work better, not necessarily look any better. Now, this is just the proof of concept with a breadboard, and this will be pretty easy to tidy up onto a little perf board, and I'll be able to stick it down in there where everything else previously was, because the pump was originally kind of stuck down there, and the reason it's lifted up like this is because I had to. I used the original tubing here, which was going to this black piece here, which has this little membrane in it, and this is what is used to kind of foam up the soap, and which we're no longer using. So this just goes straight out to this little nozzle piece here, which I actually took right off of the original hand sanitizer here. So it's the same piece there. So I just kind of ripped that off, cut that out, and the tubing fits perfectly right over that little piece inside there. And it gives you a real nice spray now. And the control board for this was actually a pretty nice design. I was surprised by this. But we're not going to use this anymore, because now we will use the AT Mega 328 board here, which is my own design and is programmed from the Arduino IDE. And what's nice about this board is that it's all about low power. There's no added components to this, no added regulators or anything like that. We'll be able to run this straight off of the lithium battery. And originally they had an 18650 cell in there, which I may use, or maybe a lithium battery like this. I think this is 1100 milliamp hour battery, something like that. And we'll just run it straight down, and this has the protection circuit in, so it'll automatically cut out at 2.8, 2.9 volts or whatever. So no big deal there. And all of this circuitry in here is pretty simple stuff. I'll pull up a schematic here in a second. But this is just, a couple resistors. There's a MOSFET for controlling the pump there. And then just some simple resistors here going down to the IR LED and receiver down there. So, I've made videos on low power design with the AT Mega 328. And in this case, because we need to always detect somebody, putting their hand in front of the dispenser, we need to run this whole thing on a timer. So in the code, basically what we're going to do is use the watchdog timer of the 328 to wake up at some interval. And this is the beauty of taking control of the dispenser, because you can change this and improve the battery life if you want. So right now I wake up once a second. So every second I wake up, check to see if there's a hand there or not, and then go back to sleep. So before I get in too deep to this, let's just take a quick look at how I improve the battery life. So this is where things get fun for me. We're applying 4 volts here, and you can see the average current is about 41 microamps or so, which is a dramatic improvement over the 270 microamps that we saw with the stock dispenser. So I'm really happy with that, but I'm still not perfectly happy. I think there's a lot of improvement here even with this. This is a quickie kind of project. This was my starting point. I think we can really improve this. And as we go along here, I'll explain some of the things that can be done to improve that. So you see these little peaks here are separated by about 1 second, because that's how often we sample the IR sensor there to see if there's a hand present or not. And if we zoom in on one of these peaks, you'll see how long it takes to do that sample. It's a couple milliseconds, maybe 6 or so milliseconds of total on time. And again, we're using that watchdog timer to sleep in between each of those peaks. So if we take a new sample here, we'll just look at that average current, and you see it's about 5 or so microamps from the 4-volt battery supply. So that's really good. So what we need to do to improve this battery life would be to either sample less or control our on time. So when we're on, do some tricks to reduce that on time as much as possible. And with everything, there's trade-offs. So the less on time you have, the less accurate you can be with the IR sensor. And I'm kind of right now just kind of playing around with this. I think I'm right on the border of that being, because with this IR thing, you don't want it to have any false positives. And even now, it still does kind of like as I'm waving my hand around here, sometimes it'll actually trigger it. But so far, I've been using this for a few days now, and this has been sitting by a window, so there's been some sunlight coming in, and I haven't seen any false positives at all with it. So I'm pretty happy with this, and I think there could be some improvement. So now let's dig into how this thing actually works. Yeah, so let's talk about this schematic a little bit here. And I just kind of threw this diagram together, but everything you see here is what's piled up on this breadboard. And what's funny was originally I wanted this whole thing to be, a little bit more complex with time of flight sensor, and I was going to add a trig board to it to make it IoT enabled, and I was like, screw all that. We'll just make it better. Lower power, we'll make it, fully controllable, all that good stuff, and just make it a better hand sanitizer dispenser. So anyway, I threw out the idea of using a time of flight sensor because the IR board that's clamped inside there below here is mechanically designed pretty well. It's got the IR LED and the photodiode in there with a little gasket. I'm firing off this thing like crazy. But it was actually kind of a pretty good design, and once I tested it out, I was happy with it, so I just went with it. And over here on the schematic, you can see the IR LED and the photodiode or IR receiver. And these values here are kind of just guesses. I started with a higher resistance to drive the IR LED and then worked my way down because the more IR light you have, the more is going to be reflected. But the more IR light you drive at, the higher that current is going to be. So you have to find like a perfect balance, of sensitivity versus your standby current. So you're kind of playing with a lot of different variables here. And again, you can continue to play with those. Like, let's say you don't want, you want this thing to be insanely low power. Well, in that case, maybe you don't need to detect a hand very low. Maybe you work your way up so it has to be like within an inch of that IR receiver. So you can kind of play around with things like that to get even better battery life out of this. And I know I'm rambling on here, so I'll just kind of explain what's going on here. So you see D2 there is digital pin 2. So when it wakes up, it's going to drive that pin high to enable the IR LED. So these two resistors here are the current limiting resistors, which, by the way, everything you see here, the way I built this up, is just with stuff I had laying around. Now, if I was to design this thing for real, I would hopefully have a spec for the IR LED and photodiode here so you can design this whole thing to an actual spec, but also all of these parts here I would actually dial into some actual real values that work for this. And the other side of that IR LED just goes straight to ground, so that's just an LED circuit there, no big deal. The photodiode looks kind of similar. You see digital pin 6 goes high when we wake, and that's essentially enabling the photodiode. So we're passing, a tiny bit of current through the photodiode to ground. And the way this works is when it sees IR light, it's going to conduct more. And what we'll do then is tap right here at the anode of the photodiode back to an analog pin, and we're going to monitor that voltage there. So the more IR light is reflected, then the lower this value will be. And in the code, we'll talk about this, how I'm doing, how this works. But essentially, when we wake, we take a dark reading without the IR LED on, and then a hot reading with the IR LED on. So off and then on. Yeah, and then to control the motor, no big deal there. That comes up with the red and black wires here. We've got the flyback diode there. Again, this is just what I had laying around. And same thing with the MOSFET. Now this, you want to be a pretty decent sized MOSFET. Something, a couple lamps maybe. You want it to have a VGS, that's going to be compliant with what we're putting out here, a digital pin 3. When this goes high, we turn the motor on. So that's your VBAT. So anywhere from 2.9 to 4 volts, we want this to be able to turn on. And this is actually a surface mount part that I just soldered on a couple little pins to make it breadboard friendly. Again, if you had a TO220 package or something a little bit easier to work with, that would work obviously a whole lot better for you. And we got the pull down obviously there, the 10K to ground, and this is a low side switch, so when this pin goes high, it turns this N channel MOSFET on, pulling that negative pin there down to ground, turning the motor on. Yeah, so that's all there is to it, and I just want to mention again that these values here were all kind of trial and error, playing around, especially these two resistors here with the photodiode. I think I started out with a 1 meg resistor and then worked my way down. And basically what I was trying to get at was a value here that was, kind of stuck at VBAT for the dark reading. And then I would see some significant change when there was reflectance here off of the IR LED. So hopefully that all makes sense. And if you have any questions, feel free to leave a comment below. Now, we can dive into the code and I'll show you the inner workings there. So here's the code all written in the Arduino IDE, and down at the tools drop down, this is based again on my ATmega 328 board, which I'll have a link to in the description below if you're interested in this. But you can target that by selecting the Arduino Mini here. It's the ATmega 328P. And I also have a hold on one sec. And to program it, I also have my own USB to serial converter that plugs right into the board, so you can target that very easily, program your board, and you're good to go. I know, sorry for the little commercial there, but anyway, this is just the stuff I use for my own projects. So anyway, so there you have all of your pins, the IR LED, the photodiode pin. This is the power to the photodiode. And then the analog pin back is analog pin 0, and then the motor pin is digital pin 3. And this is the percent change. This is like the threshold value you would use. So I have it set to 10%. And we're going to get into what that means exactly here in a second when I show you how this thing actually works. So we'll come back to that. And all your variables here that will make more sense as we move along here. So in the setup here, nothing too special. We're setting up those digital pins. We're going to use the serial monitor. Right now is meaningless because we have nothing hooked up, but for debugging, this is especially useful. Again, my USB to serial converter or any 6-pin FTDI device will work here. Now, I'm not going to talk too much about the sleep modes here because I made an entire video about it, which is linked right here. And the sleep code you see in this code is all copied over from what you saw in that video. So if you want to see more information about using the watchdog timer, go and watch the video linked here. So now we're in the loop here, and the first thing we do is go to sleep. So we have a go to sleep function, and we're going to pass a 6 to it, which is a 1 second sleep time. And again, I'm not going to get into this too much because this entire function here was copied right out of that video. And so you see here, though, a 1 second is a not a 1, but a 2 and a 4. So 4 plus 2 is 6. 1 second sleep time. And if you wanted to modify this in any way, you can make it anything you want here. Like maybe you feel that a 1 second time when you put your hand here is not fast enough. Maybe you want that to be 0.25. Or maybe, you know what? I could wait another second, so I'll put it at 2 seconds. So within 2 seconds of putting your hand there, you're going to get your hand sanitizer. And that's going to significantly improve battery life. But going back up to the loop here, you'll see right after we sleep, we wake up, and this is where that happens. And the first thing we do is set up the photodiode. So we're going to apply that power right here to digital pin 6. So we've got now power going through the photodiode. We do not have power through the IR LED because we first want to grab the dark reading. So this is with no IR LED active because there's always going to be ambient IR light around this thing. So that's why we want to grab that first so that we can subtract from that when we take our hot reading. So after we get our dark reading, we're going to fire up the IR LED and then wait 1 millisecond for that. Then take the IR reading. So now we have two readings. We have a dark reading and the IR reading, which, it's the hot reading. It's the reflected reading that we're going to get from the photodiode. And immediately kill power to both of those. We're always trying to conserve power here, so we only keep things on as long as we need to keep them on for. Now I just want to point out that these two delays here are critical to the way this works. Now obviously if you keep your IR LED on for longer, you're going to have more reflected IR light back to the photodiode. So you're going to have a better reading of if, there's a hand there or not. So anyway, these can be played around with, and, for a 2 millisecond delay there to get your dark reading, and then another 1 millisecond there for the hot reading. These seem to work pretty good, but again, you can always play around with these. So then we're just going to modify the IR reading by subtracting away the dark reading, and then let's get it away from 0, and I just added 100 to that. And this is kind of just, a random thought I had, so bring it up closer to 100, so they're not dealing with negative numbers and all of that kind of stuff. It's just a little bit easier to deal with. So you gotta love my coding there, but anyway, we're not gonna talk here about the preload count or when we actually detect a hand, because most of the time there is no hand there. All day long, it's just sitting here on a shelf or on your counter doing nothing. So let's talk about that first. So the preload count doesn't matter, and this doesn't matter. So if all that is true, then it'll actually spray you. Otherwise, we're down here. So we have some booleans here. We're going to say hand is present is false. And then hand count, which we'll talk about, we reset to 0. And then right here, basically what we're doing is keeping a rolling average or a running average of the readings. So we have 20 readings that we're using, which again, another variable in this whole mix that you can modify. 20 just seemed to work pretty good. So we've got 20 readings that we're rolling through, and this loop here just moves them all one over, pushes the last one out, and then puts the new one in position 0 that we just took. And then we take an average of all 20 readings, and we have this running average. And the reason we're doing that is because we're going to compare the new reading that we get at once a second against that running average. And this is good because we're always having, a changing environment. People walking by, the sun is rising, there's a cloud kind of covers the sun up. This is by a window. We don't want a sudden change to trigger this thing. So we've got this running, slow moving average that spans 20 seconds worth of readings. And we're also running this whole thing from a battery that's also discharging. So we can't have like a fixed, if the IR reading is ever below this value, means that, there's a hand present. So it's good to do it this way because, things are always changing in this system. And we know that a hand is not always present. So we'll do this running average continuously to get a baseline of what no hand looks like. Okay, so now I can talk about what a preload count is. And basically, this is on power up. So when this thing is powered up for the first time, we don't want it to range and detect a hand. So that's why we have this. We count 20 up from this preload count here, and we want to fill up that full running average array with values before we ever spray anybody. So when you power this up, we have 20 seconds and it's learning its environment. So the dispenser's never going to spray your hand for that first 20 seconds it's powered on because the preload count would be less than 20. So this is never fired here. It's always going to go down here and go through and fill up that entire array with 20 values before it ever tries to detect if a hand is present or not. And that's important. So once we exceed the 20 preload counts, we no longer have to count it. This here goes true. So now we can actually use the IR reading and check it against the running average. Now, what are we detecting or what are we, checking it against? That is that percent change constant that we have up here. And I have that set for 10%. So that's 10% less than the running average. So if our IR reading here is less than 10% of subtracted from the running average, then we will spray your hand. So you see that's right here. So we take the percent change times the running average and subtract that away from the running average. And if our IR reading is less than that, then we're going to go and spray. So you see what we do right here. So for debug purposes, we throw out a hash and a little delay there because this all happens so quickly. We need a little delay so that the serial output goes out before we go back to sleep. Now I'm going to talk about the hand count here in a second because that was something I added in later on. But one thing I did want was if somebody put their hand here, I didn't want it to just keep spraying all day long. I wanted to spray once and then stop until, it went back to seeing the running average, the normal running average or the normal like dark values, and then reset itself. So that's why right here. So if it was not there, that means that, it's a new hand there. So we're going to set the hand as present to true. So if this came back on through here, this would still be set true and this would not fire again. So it only fires once when it detects the hand. And like we saw here, when there is no hand present, this is set back to false. Okay, but we see it for the first time. So we're going to come through here, give you some debug output of what the reading is, the running average is, the percent change, and then fire up the motor for 500 milliseconds, which seems to be a pretty good value there, and we get a pretty good spray, which is nice again from the stock dispenser, which kind of just like dribbles a little bit out at you. This we have complete control over, and if you want to spray more, you can. So what's this hand count all about up here? Well, let's say somebody moves the dispenser to another area where you've got, like right here, we've got this white surface. So more IR light is being reflected. Well, sometimes if you move it, you're going to see a spray. And what ends up happening is it always thinks that a hand is present because it's in a new location. So the running average is never recalculated. It always thinks a hand is there. Now, it's not going to continuously spray because hand count or hand is present will always be true. It never resets itself. So what hand count does here is increment every time it thinks a hand is there, and then after 20 or 20 seconds, it's going to reset the calibration by simply setting the hand count back to 0 and the preload count back to 0. Now the preload count is critical because that then will disable this from ever firing, and it's going to grab 20 fresh readings down here for the running average. So it's going to relearn its environment. And even like if you get a sudden false positive from like I said, if you move it or you open the blinds, big deal, it sprays once, relearns the environment after 20 seconds, and then it's good again. And I think that's all I've got on the code right now. Now, one thing you might want to do, and this is what is done with a lot of these IR type sensors, is once it thinks a hand is present, it'll actually go and double check that, or maybe, triple check it, or a couple times anyway, in a row to make sure that a hand is present before it actually sprays. So that might be something I add to this, but you know, to me, just because I love the low power aspect of this whole thing, I'll probably spend more time on reducing the current draw from the battery in that standby mode. And I might add IoT to this. I don't know. I might do that. I don't know what I would do with it. I mean, I guess I could send a push notification to my phone when it's used. You know, maybe a fun project would be to like unlock your computer if the hand sanitizer is used, or, you know, turn the lights off or unlock a door. You know, I don't know. I don't really know if there's a good use case for adding IoT to a hand sanitizer, but anyway, that's the project, and I will button all of this up. I was going to do that in this video, but with the 328 board and tuck all of this in, you know, maybe even put the cap back on. I don't know. And by the way, I've got links to this hand sanitizer, or this soap dispenser anyway, and the hand sanitizer that I'm using here, all at the top of the code, all of the parts. This code's up on GitHub, everything you want to build this. If anything, I think this was just a fun project to reverse engineer something like this and kind of try to, you know, get it to work, you know, the way it is. But anyway, you know, hopefully you found this kind of interesting. This was a fun project for me, kind of a change from a lot of the stuff I've been doing. So thanks for watching.